Free-falling motion by John Paul Araneta and R.J. Piano. Here are the objectives. To understand the concept of free-falling motion, to demonstrate, observe, and compare the free-falling motion of different objects through dropping bodies at an equal height.
Free-falling motion is a fundamental concept in physics that describes the motion of an object falling under the sole influence of gravity. It occurs when an object is released from a height and allowed to move freely in the absence of any other force except gravity. This type of motion is commonly observed in everyday situations, such as dropping a ball from a certain height or the motion of a skydiver during free fall. In free-falling motion, the object experiences a constant acceleration due to gravity, which is approximately 9.8 meters per second squared near the surface of the Earth. This acceleration, often denoted as g, causes the object to gain speed as it falls towards the ground. As a result, the velocity of the object increasing over time, leading to a continuous change in it. Is important to note that free-falling motion assumes the absence of air resistance, which can significantly affect the behavior of objects falling through the Earth's atmosphere. In ideal conditions, however, free-falling motion provides simplified framework for understanding the fundamental principles of motion under gravity. Observation. From the procedure, which includes drafting of two bodies with different mass, masking tape, and coin force, it was observed that two objects reached the ground at the same time. Moreover, from the third procedure, which include a solid object and uncrumpled paper, it was observed that the paper falls lower compared to the tape. Moreover, from the fourth procedure, it was observed that the crumpled paper falls down at the rate similar to the tape.
The conclusion: the two bodies with relatively different masses will nevertheless strike the ground at the same time if they are dropped from the same height, because Earth provides them the exact same acceleration. Moreover, the presence of the air resistance in the uncrumpled paper causes it to fall down slower than a solid object. The air is pushing the paper surface opposite to the Earth gravitational force. On the other hand, the crumpled paper loses most of its surface compared to the uncrumpled one, which one lesser air resistance. Due to this, the paper and the solid object reach the ground at the same time. Guide question 1. Does the mass affect the speed of falling object? The mass does not affect the speed of falling object since there are gravity that acts on it. Earth gives everything the same exact acceleration. Object will hit the ground if they are dropped from the same height, regardless of its mass. Number 2. Why does the crumpled paper take longer time to reach the ground? The crumpled paper took longer time to reach the ground due to the presence of air resistance causing it to slow down. The crumpled paper has more surface area, which means it has more air resistance as compared to crumpled one.
Is there a force that is pulling down the object that causes it to slow down after it was thrown? What is the direction of the force, if there is?